Hello, friends, and welcome to the first lesson in Topic 8, Topic 8-1. You will be able to do most of this lesson as you follow along, either on a whiteboard with a dry erase marker and eraser, or in your books or on a blank piece of paper. Just follow along. If you're on a touchscreen device, you can do that on there as well. All right, let's go ahead and get into it. Topic 8-1. We're going to start with some warm-ups. Here we go. Okay, go ahead and follow along with the dot as I read. Sandra counted the number of legs walking in the park. Interesting. She counted a total of 7 people and some dogs. Each person had 2 legs, as people tend to. Not everybody, but most. And each dog had 4 legs. There were 22 legs. Now here's our question. How many legs, how many dogs, I'm sorry, how many dogs did she count? How many dogs did she count? All right. That means there's going to be a little bit of a hidden question in there. We're going to have a little bit of a hidden question there. All right. How many dogs did she count? That's what we want to find out. And let's see. Well, here are our choices. 2 dogs, 3 dogs, 4 dogs, or 6 dogs. Why don't we go ahead and get into this? Because it's a warm up. I want you to see, did you see the hidden question here? Do you need to find out how many people legs there are first? Yes, you do. You do. So how do you do that? Well, she counted a total of 7 people. How many legs did each person have? We're talking about equal groups. So what do we need to do? All right. How do you do that? 7 times 2. 7 multiplied by 2. Multiplication deals with the adding of equal groups repeatedly. So 7 times 2. What is that? Well, what do you need to do next? Now what do you need to do? 22 minus 7 times 2 equals what? All right. And then once you figure that out, you're going to divide it by 4, aren't you? Because how many legs do dogs have? That'll tell you how many legs there are. All right. So how many dogs did she count? I'm going to give you a few more seconds to figure that out. If you need a little more time, go ahead and pause the video. We're going to check our work in 3, 2, 1. Go ahead and check your work. She counted 2 dogs, 2 dogs. So 7 times 2 equals 14. 22 minus 14 equals 8. So 8 divided by 4 equals 2. Or 2 times 4 equals 8. Go ahead and check your work that way. All right, now that we're a little more warmed up, we're going to take the training wheels off. Let's get into our next question. Here we go. All right. A contractor drew these plans for a new deck. What is the area of the deck? Okay, we need to find the area. That's all of the space inside these lines here. How do we do that? Well, we've got lengths here, and we multiply length times width on rectangles and squares. Remember that from topic 6, okay? So what do you need to do to figure that out? All right. What is the area? Let's see if you can figure it out. Is it 9 square feet, 28 square feet, 36 square feet, or 45 square feet? All right, what do you need to do? Go ahead and pause the video if you need a little bit more time. We'll go over how you figure that out shortly after we reveal the answer, but let's see what you remember. All right, pause the video now if you need more time. And check your work in 3, 2, 1. Here we go. Oh, the correct answer was 45 square feet. 45 square feet. All right. So how do we figure this out? If, in case you forgot, we need to make this irregular shape into a regular shape. Okay. So what we need to do is we need to separate it into two shapes that are regular. So we draw a line maybe right here. That's one way to do it. We got to figure out the area here and the area here. Well, this one's pretty easy because we know that it's 9 feet long this way and we didn't cut it across anyway, and it's 4 feet this way, okay? So 4 times 9 equals what? It equals 36. Pardon my terrible mouse drawings. Here we are. 4 times 9 equals 36. Okay, well, how do we figure out this area right here? All right, well, we know that this side is 4 feet long and this is 7 feet long. So if it was all the way square like this, it would be 7 times 9 to figure out the whole area, but we've got this cutout right here. So we need to take 7 feet right here, and to get the length of this part right here, let me go ahead and change the color. I'm gonna give it a little bit wider, more like a highlight, like a yellow, this length right here. All right, we need to subtract from 7 the 4 that's over on this side, right? Because we're not going to be adding up this side. So to find out this one, we would do, well, 7 times 4, what does that equal? Equals 3. All right, 3. And then this one's 6, and this one is 9 up here. Okay, we see that? This part right here. Well, we're going to subtract the 6 off of that. So we've got one of our factors for this side right here. It's 3. And then 9 minus the 6 feet we don't need here is also 3. 3 times 3 equals 9. Well, how do we find the whole area there? Well, 4 times 9. Okay. Well, we're going to add one more 9. All right. What is 5 times 9? 5 times 9 is 45, or you could just add 36 plus 9, and that equals 45 right here. All right, we understand that. Great. Let's move on to our last warm-up question. Here we go. All right, let's take a look at this graph. We just finished our topic on data and graphs, and a lot of you understood that a lot better, but a few things we need to pay attention to as we go along. But let's go ahead and read the question. Which teams read fewer than 24 books? How many books did those teams read? So, how many question marks do we have here? We've got one right here and one right here. All right, go ahead and show me your work, but we need to figure out which teams read fewer than 24 books. Well, let's first take a look at our key. Our key tells us what each symbol in a picture graph means. So an entire book symbol equals 4 books, and a half of a book, or one of those little parts of a book there, equals 2 books. All right, I'm going to let you go ahead and figure this out. Go ahead and pause the video if you need a little more time to figure out which teams read fewer than 24 books and how many books those teams read. Okay, let's go ahead and check back in on our work. Which teams are they? Well, Team A read 18 books. Okay, so is that fewer than 24? Yes, Team A read 18 books. And which other one did? Well, there's another one that read the same amount as Team A right there. Team C read 18 books. Are there any other ones? Well, no, this one and this one both read more because 4, 8, 12, 16, 20, 24, 28, 30. So Team B read 30, 6 more than 24. And what about Team D? 4, 8, 12, 16, 20, 24. Oh, they read exactly 24. Okay, so only teams A and team C did not or read fewer than 24 books, and they both read 18. All right, let's get into what we're learning for today. Here we go. Okay, what are we learning today? Today, I am learning how to solve addition problems using the properties of addition. Okay, we've been talking about properties of multiplication a lot so far this year, but now we're going back to addition, and addition actually has properties just like multiplication does. So keep that in mind as we go about today. We are learning how to solve addition problems using the properties of addition. By the end of today, you should be able to say, I can solve 1- and 2-step problems using the properties of addition. Also, by the end of today, you should be able to say, I can use an open number line to model addition properties. And you should be able to say, I can use properties of addition to find the missing number in equations and expressions. Ooh, that's fun, finding the missing number. All right. Any more? No. Let's go ahead and get into our avatars for today. Which avatar friend would you choose to work with on this topic and why? All right. Jackson, Zeke, Emily, Alex, Daniel, Jada, Marta, and Carlos. Those are our avatar friends. Let's go ahead and get into it with our solve and share question. All right. So for this one, you do not need your books. Let's go ahead and read right here our big green box. We start by reading the big green box. Go ahead and follow along as I read. Olivia arranges cups of buttons on 3 trays. Okay, we see tray A, tray B, tray C. She records the number of buttons on each cup. Which tray has the most buttons? Okay, there's our question. Which tray has the most buttons? Use place value blocks or drawings to help solve the problem. All right. All right. Oh, Marta is our avatar helper in our solve and share today. She wants us to know, or she's got a couple of questions that will help us figure it out. Are you making the same calculations more than once? How can you use structure to help solve the problem? Ooh, all right. So, what do the different numbers on each tray represent? Let's think about that. Well, the number of buttons on each cup. All right. She arranges cups of buttons. All right. Hopefully, we know what that means. How will you use the numbers to help solve the problem? Now, remember, the problem says which tray has the most buttons? Okay. Which tray has the most buttons? All right, let's see if we've got any solution shares. If you need a little bit more time, go ahead and pause the video right here. But we're going to get right into reviewing the solution of someone else and checking it for reasonableness. Let's see whose solution we're reviewing today. Again, if you're still working on the solution, pause the video now. Here's the one we're going to review for today. Marco's work. Marco. Okay, so what did Marco do for his work? He said 18 plus 24 plus 22. So he added these 3 together. All right. Added 18 plus 24 plus 22 equals 18 plus 22 plus 24, which equals 22 plus 18 plus 24. Okay. He figured out that each of those 18 plus 24 plus 22 equals 64. And 18 plus 22 plus 24 equals 64, and 22 plus 18 plus 24 equals 64. Here's the important part. What do you think about what he said right here? The sum is the same on each tray. Changing the order of the numbers does not change the sum. So you can see that each of the 3 cups have the same amount in there, all right, on each one. All right, we see an 18 a cup with 18 on each tray, a cup with 24 on each tray, and a cup with 22 on each tray. That's going to be one of the main takeaways of today's lesson. All right, let's go ahead and get into our visual learning bridge. Here we go. Okay, so if you haven't already, go ahead and log on to Savvis and view the assigned video for this topic, 8-1 Visual Learning Bridge, if you are able to do that. If not, we're going to go over this really quickly on our video here. So our essential question today is, what are some properties of addition? Well, they're going to have similar names or exactly the same names as properties of multiplication, okay? You can use properties of addition to join groups. Now, Marta's got some very, very important information for us here, okay? Ooh, parentheses, parentheses, show what to do first. Now, this is going to be something that carries throughout the rest of your math journey as you get into middle school and high school in math. The parentheses around something say do me first, whether that's addition, okay, or subtraction, or multiplication. All right, multiplication or division, whatever it is that's inside the parentheses, you want to do that first. Okay, that was a little bit of a tangent, but I wanted to make sure that that was something you understood because it's coming up now and it will continue to come up all the way throughout math. All right, let's get into our first property. Where have we heard the word associative before? And also in parentheses, grouping. All right, grouping. When we group in the parentheses, that's what these little boy things are right here. Okay, I guess they're punctuation of some kind, but these are parentheses. All right, open parenthesis, closing parenthesis, and they group things together. So you can group add-ins in any way, and the sum will be the same. Interesting. So just like the associative grouping property of multiplication, where you can group factors in any way, and the product will be the same, you can group add-ins in any way, and the sum will be the same, okay? 18 plus 14 plus 15 equals 47. And 18 plus 14 plus 15 equals 47. All right? And they just show it like that right there. Okay? Let's go ahead and look down at the other parts, our other properties. Here we go. Okay, so once again, we've got another familiar one, the commutative or commutative order property of addition. That's talking about the order that they come in as far as when they show up in our equation or expression, okay? And it just states you can add numbers in any order and the sum will be the same. So if I've got 57 plus 35, it's going to equal 35 plus 57. And you can see that right there. We've got 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6, 7, 57, plus 10, 20, 30, 1, 2, 3, 4, 5, so 35. 35 over here, 57 over here. We have the same amount of things. So you can add numbers in any order and the sum will be the same. All right. Now, the identity, zero property of addition. This is where things might get a little bit tricky for you because if you remember the identity, okay, the identity property was in multiplication is the 1, right? So here it's the zero property. Now multiplication has its own zero property. So I want us to make sure we understand what that means. If it's an identity property, that means that the other add-in plus 0 is going to be itself. It identifies as itself. 18 plus 0 equals 18. 39 plus 0 equals 39, okay? As where with multiplication, it would be 39 times 1 would equal 39. Does that make sense? All right, if you're confused on that one, it's okay. Just remember that that's where it gets a little bit different, all right? So, not to get confused, we are talking about addition today, not multiplication. Okay, not multiplication today. All right. Okay. So just remember that any number, the sum of any number, okay, is that same number. The sum of 0 and any number is that same number. So if I've got 39 here and 0 here, I've still got 39 things. Do we see that? We'll just take that bar away, add them together. Still the same thing. All right, let's do a little guided practice. Okay, we're going to start with the do you know how questions. All right, if you're working along with a piece of paper, let's just identify these. Let's see if you can identify which property is being used here. We always want to read the green box because that's telling us what we do. So do you know how? All right, I'm going to let us do that for a couple of seconds, do number 3 and number 4, and then we're going to come back and check them in just a moment. Go ahead and pause the video if you need more time. Okay, so number 3, what is the property that is being shown here? What is the property that's being shown here? It is the associative or grouping property of addition. We can see that the add-ins are all the same and they're all in the same order, but the way they were grouped is different. So 4 plus 15 plus 26 equals 4 plus 15 plus 26. All right, the add-ins are the same on both sides. Doesn't matter which order you do it in. Okay, what about this one? We just got done talking about that one. All right, so for addition, 17 plus 0 equals 17. What do we call that? We call that the identity or zero property of addition. All right. If I've got 17 jelly beans and I add 0 jelly beans, how many jelly beans do I have? Well, I've got 17. All right. So anything added to 0 will be that number. Okay. All right. Go ahead and write each missing number here. Use the properties that we just talked about. If you do have your book and you need to look back at those properties, you can do that. I'm going to give us about 10 seconds to pause the video if you need more time to fill them out. Okay, let's go ahead and get going on this one. All right, what plus 90 equals 90? Well, this should be a pretty easy one. We just talked about it. 0 plus 90 equals 90. All right, so number 6, 42 plus 23 equals 23 plus. Ooh, sounds a little bit like the commutative or commutative property here. What do we need to put in that blank to make it balance on both sides? If 42 plus 23 equals, oh, we need the expressions to equal. We've got a 23 on both sides. We also need to have a 42 on that side as our missing number. All right. And lastly, ooh, what are we doing here? Interesting. Now remember, we've got this equal sign, so this side needs to equal this side. We see we've got a 2 and a 2 and a 36 and a 36. They grouped them differently on both sides, but does that matter? No, it does not matter. So what number needs to go here? What is the missing number? It is 23. All right. If that seems pretty easy for you, kiss your brain. It's designed to be pretty easy. If it's difficult for you still, that's okay. We can work on you understanding it more as we move along. All right, let's go ahead and see where we're at. Ooh, that's right. We need to do our do you understand ones. Okay, let's go through this quickly. Ralph says he can rewrite 4 plus 5 plus 21 as 9 plus 21. Do you agree? Why or why not? So 4 plus 5 plus 21 as 9 plus 21. Do you agree? Why or why not? Okay, so that's going to be a yes or a no. And then you need to tell me why you're saying yes or no. Go ahead and pause if you need a little bit of time to respond. But we're going to move forward in 3, 2, and 1. Okay, so do you agree? Yes, you should definitely agree. Okay. But why? Why should we agree that he can rewrite 4 plus 5 plus 21 as 9 plus 21? The parentheses. All right, our friends, the parentheses right here show you which numbers to add first, just like we talked about a few minutes ago. All right, so you add 4 plus 5, and 4 plus 5 equals 9. So 9 plus 21. All right, easy peasy. Here we go. Let's move forward. Oh, what property is shown with this equation, and how do you know? What property is shown with this equation, and how do you know? All right. Are they grouping them differently, or are they ordering them differently? Okay. This is where some of us get confused. I want you to look at the grouping. All right. The parentheses. If they're the same, something is a different order, then what property is that? How do you know? All right. Go ahead and check your answer in 3, 2, 1. It is the commutative property of addition. Okay. Commutative. Sometimes we get that mixed up with associative, but we can see that they've grouped these the same. But what's in a different order here? 65 comes first on this side of the equation, and it comes last on this side. But they balance because our add-ins are still all the same. 65, 18, and 38 equals 18 plus 38 plus 65. All right. Yeah, the same numbers are added, but in a different order. All right. Okay, how are we feeling about this right now? Thumbs up, I can do this. I am ready to move on or explain to a friend. All right, thumbs to the side. I'm almost there. I may need more practice or help. And thumbs down. I don't understand. I need more work or help on this. Go ahead and rate yourself. We're going to get into today's independent practice. Here we go. All right. Oh, we've got a higher order thinking question coming right out of the gate. All right. Go ahead and read this one to yourself. I'm going to let you read this to yourself. Go ahead and pause the video and read it. Okay. Now, I want us to pay close attention to this word right here. Subtract numbers in any order. So, can you subtract numbers in any order and the difference, will it stay the same? Now, remember, you need to give an example to support your answer. Okay, so I'll go ahead and do that. Pause the video right now. Okay, we're coming back in 3, 2, 1. All right, go ahead and take a look at the example I've got here. Undoubtedly, the numbers will be different, probably, but go ahead and check and see. Is Barry correct? He says he can subtract numbers in any order and the difference will stay the same. So, is he correct? That's our first question right here. No. He is not correct because we're talking about subtraction. Okay, here's our sample answer. All right, 34 minus 12 equals 22. Okay, is that true? Yeah, 4 minus 2 is 2. 3 minus 1 is 2, or 30 minus 10. 30 minus 10 is 20. So 20 and 2. All right, but 12 minus 34 does not equal 22. All right, so that does not apply to subtraction. Okay, let's move on forward. All right. Thumbs up when you finish before moving on. That's if you're in class watching this video. But if you're by yourself or with a small group of people, pause the video right now. Here's our assignment for today. We're going to do numbers 9 and 11, 13, 15, 17, and 19. Now, do you need your book to do this? No, you can pause the video right here and do it on a piece of paper. That's totally fine. But what do you need to do before you go off into each of these sections? All right. By the way, it's page 291 in your book. All right. Okay. So in 8 through 11, So 9 and 11 qualify as being in 8 through 11, right? Identify each property. So what are the properties that they're using right here? And in 12 through 19, you're going to write each missing number, just like we did in guided practice. So go ahead and pause the video right here. Give yourself a few minutes to do it. And then we're going to see what we're going to do for problem solving today. Okay? Okay, we are going to move on to problem solving. Here we go. All right, it looks like we are doing number 21 and number 25 today. Do you need your book? Not necessarily. You just pause right here and do those with a piece of paper on your whiteboard on a touch screen if you're viewing this on a touch screen, okay? So number 21, number 25, all right? Then when you finish, I want you to log on to Savas and do your 8-1 quick check. See me if you get an 80 or 100% for your extension activity. Otherwise, you're going to get another fun activity, the additional practice buddy, in your backpack in Savas to complete. Okay? All right. Good luck with all of those. And let's see, we can go over these at another date, but for now, we're just going to move on to how you feel about answering these questions. Okay. How do you feel about today's lesson about the properties of addition? All right. The commutative property, the associative property, and the identity property. Commutative, associative, and identity properties of addition. Okay. Again, thumbs up. I can do this. I'm ready to move on or explain to a friend. Thumbs to the side. I'm almost there. I need more help or practice. And thumbs down. I don't understand. I need more work or help on this. All right. Go ahead and let me know if you do need more help, and I will check your quick checks as well. If we're doing that quick check and getting anything below like a 60 or 40, 60, 40, 20, 0, we definitely need to do that additional practice. If you get an 80 or 100, you pretty well know how to do this. Okay. All right. Excellent work today, friends. Give yourself some credit for an excellent lesson, and I will see you in the next one. Bye-bye.